So here is the most important part when we are talking about drying process. In drying process, it is usually desired to estimate the following three. The first one is that the size of the dryer that we need. The second one is that the operating condition of air, if let's say we are using indirect drying. And then the third one, which is the most important one, is actually the time required for our drying process. Now, when we are saying that we want to design a dryer, these are the three things that we want to look at. Because if let's say you have a specific product, when you want to see, when you actually want to know how big your dryer will be. So that's why you need to know what kind of material you have, what kind of dryer you want to use, what kind of process you want to use. So based on that, based on the amount of material that you want to dry, you can actually determine the size of the dryer that you want. The second one is that the operating condition of air. So remember, some materials, some products that you have might be sensitive to high temperature. So based on the characteristic of the material that you want to dry, you will have to choose the appropriate condition of air here. Meaning here, when we say condition of air, it can be in terms of the temperature, right? Do you want to use air at 100 degrees Celsius or maybe only at 50 degrees Celsius? So you can also consider about the velocity of the air. How fast is the air coming in contact with your material? Because if you have high velocity and high temperature, maybe your product will dry quickly, but what will happen to the final characteristic of the product? Will it be the best characteristic that you want, or it will ruin the product? So that's why it is important for you to actually know the operating condition of the air. And finally, you also want to consider the time required for drying. So based on selecting your condition, you are actually also selecting how fast your material will dry. So this again depends on the characteristic of your product. So in order to achieve these three things, we must first define a few important parameters. The first one, okay, this is one of the most important parameter and we'll be using it throughout our class. The first one is known as moisture content. Now, moisture content can be defined in terms of the wet basis and also the dry basis. So in terms of the wet basis, moisture content is basically just the amount of water in the solid. So how much more, if you have more water in the solid, you will have a higher moisture content. If you have less amount of water in the solid, you will have a lower moisture content. And the unit for moisture content, the symbol for moisture content that we'll be using is X, okay? And the unit here is going to be kg of moisture per kg wet solid, right? So I can just write here, the symbol is X. But remember, it's kg moisture per kg wet solid. That is your moisture content in terms of weight basis. Weight basis here meaning that when we are actually considering the total mass of your solid plus your water. When we talk about moisture content in dry basis, it is still the same thing. The amount of water in the solid, but the only difference is that the unit. The unit here is going to be kg of moisture per kg dry solid. So there is actually a relationship between your wet basis moisture content and dry basis moisture content. So you have to figure out how to actually get dry basis moisture content from the wet basis moisture content. Okay, so sometimes because if you are given the moisture content in wet basis, you must be able to convert it into the dry basis. Or sometimes when you are given the moisture content in dry basis, you must also be able to convert it to the moisture content in wet basis. So it depends on the condition. So please try to figure out how to actually get dry basis moisture content from wet basis moisture content. That is the first important parameter that we need to understand. The second one is known as equilibrium moisture content. So equilibrium moisture content is the portion of water vapor or moisture in the wet solid that cannot be removed by the inlet air because of the humidity of air. So meaning that when you are drying your solid, so you will use air at a certain condition. So this is where our temperature comes into play. So if I say my temperature is at 50 degrees Celsius and my relative humidity is at 40%, so meaning that at this temperature, I can first decide that at 50 degrees Celsius, what is my saturation humidity based on my humidity or psychrometric chart. So if let's say I have a relative humidity is 40%, so this actually will dictate how much moisture can this air at this condition take. So that's why we say that if let's say we are using 50 degrees Celsius and relative humidity 40% air, so the portion of air in the wet solid that can be removed is actually depends on this condition. So whatever moisture cannot be removed, whatever moisture that is still remaining in your solid, we call it as equilibrium moisture content. Now this one, usually we have the symbol of Xe. E here stands for equilibrium moisture content. The next one is that we say that if we have equilibrium moisture content, we can also have free moisture content. So the free moisture content is the content above the equilibrium moisture content. This is the moisture content that is actually removed during drying. So meaning that whatever moisture content you remove during drying and whatever moisture content is left, we call it as equilibrium moisture content because that moisture cannot be removed based on the condition of air that we have. But whatever the quantity or how much of moisture content is removed, that one we call it as free moisture content. Now it is important for you to understand the relationship between moisture content, equilibrium moisture content, and also free moisture content. So when you have your moisture content, you can get your free moisture content by deducting from the equilibrium moisture content. Okay, so we look at this in in the next slides. So the next one, when we talk about drying, they also say that the condition of drying. So when we say that constant drying condition, so we are actually referring to the temperature, humidity, and direction of airflow across the drying surface are actually constant. So that's why we want to make sure that our temperature, our humidity, and velocity are actually constant, meaning that they are not changing throughout the drying process. So that's how we define what is the meaning of constant drying condition. So we want to make sure that our temperature will always be the same, humidity will always be the same, and velocity will always be the same. Why? Because it is actually affecting our drying process. So if it's not constant, then sometimes you can have the time required can be small, or if the temperature is too low, the time required will be actually very, very high. If the humidity is very, very high, the relative humidity is very high, so meaning that the final value, the amount of moisture that you can remove will become low. And if the velocity is also fluctuating, it will also affect the time required, and eventually it will affect the size of the dryer that you need. So that's why if let's say you want a very good drying condition, you usually operate this at a constant drying condition. The next one is that drying rates are usually obtained using experimental measurements. So before want to actually build a dryer or design a dryer, we have to run some experiments. So based on the experiments, when we actually have the data, then only we can actually design our dryer. So the data obtained are usually as W, the total weight of wet solid, meaning that dry solid plus the moisture at a different drying condition. So when we want to get the moisture content, so this is actually the total moisture content, we label it as XT. So when we want to get the total moisture content, it's just that we are minusing the kg of water per kg of dry solid. So W here stands for the total weight of your wet solid. So wet solid will have the amount of water plus the dry solid. Ws here we define as the weight of the dry solid. So when you want to get the total amount of water that is actually in your wet solid, you just take the total weight of the wet solid minus the total weight of the dry solid divided by the total weight of dry solid. So if you see here, when we do this kind of expression, automatically we'll get a unit for our moisture content, and the unit is going to be kg H2O over kg dry solid. Okay, so that's why if let's say you want to actually get your moisture content in terms of the, so we can say that here this is actually moisture content in terms of the dry basis, because we define that moisture content in terms of dry basis is amount of water in your dry solid. So that's why it is important for us to actually know, if let's say you want to change this into our wet basis moisture content, so you have to know how to change into kg of water per kg of wet solid. So for the constant drying condition and equilibrium moisture content, so if let's say we are actually drying at a certain temperature with a certain humidity, we'll have a value of equilibrium moisture content. So the free moisture content, as I mentioned, X, we can obtain X is equal to XT, total moisture content, minus the equilibrium moisture content. So when we are actually trying to design or trying to calculate the time of drying, we are actually interested in using the free moisture content, because even though total moisture content is important, because of this, our limitation in terms of the temperature and the condition of air, the amount of liquid or moisture that is actually being removed from your system is actually your free moisture content. So that is why we are more interested to know and to find this value. And this is the value that we actually will be using in our drying calculation.